Welcome to free online maths lessons. Today I'm going to take you through some example questions on using Pythagoras theory, including a real-life example. On my previous lesson, I've already explained you the fundamentals behind Pythagoras theory. To access my previous lesson on Pythagoras theory, please click on the link below. To access more lessons, please subscribe to my channel. On this example, I will explain you how to calculate the hypotenuse of a right-angle triangle using the Pythagoras theory. This is a very basic question. According to the information given for the right-angle triangle ABC, the AB length is 10 centimeters. The AZ length is 20 centimeters. And we have to find out the BZ length. We can apply simply the Pythagoras theory to this right angle triangle. Remember, the Pythagoras theory only can be applied to right angle triangles. So, using the Pythagoras theory, the BA squared plus AC squared is equal to the BC squared. BA is 10 centimeters. So we have to take the square of that. AC is 20 centimeters. We have to take the square of that. BC squared then will be equal to 500. However, we have to find the BC length. So we have to take the square root of 500, which is equal to 22.361 centimeters. The answer must be written to three significant figures. Therefore, it is equal to 22.4 centimeters. Let's move on to another question. ABCD is a trapezium. There are some dimension that is given for this trapezium. AD is equal to 10 centimeters. AB is equal to 9 centimeters. DZ is equal to 3 centimeters. We do not know the value of BC. Angle ABC and angle BCD are right angles. Calculate the length AC. Give your answer to three significant figures. Okay, I will now explain you how to approach this question. AC is the length that I must calculate. Therefore, I form a dotted line to represent the length AZ. I have formed a rectangle EBCD. On a rectangle, you know that the angles are 90 degrees. So this angle here will be 90 degrees. So does the angle opposite to it. The opposite side of a rectangle are equal. Therefore, ED is equal to BC. And also, EB is equal to DZ. As we know already the length DZ, it is equal to EB as well. Therefore, EB is equal to 3 centimeters. In order to find the length AC, we must know the length BC. Because if we know length BC, then we can use the Pythagoras theory to ABC right angle triangle. In order to find the length BC, I must find the length ED. To find length ED, I can apply Pythagoras theory to triangle AED. For that, I must find the value of AE. AE is equal to AB minus EB. AB is 9 centimeters. EB is 3 centimeters. Therefore, AE is equal to 6 centimeters. Now I can apply the Pythagoras theory to AED triangle. Applying Pythagoras theory, I can find out the value ED. ED is equal to square root 64. Therefore, ED is equal to 8 centimeters. ED is also equal to BZ because EDCB is a rectangle. Now I know AB and BZ. Therefore, by applying the Pythagoras theory to ABC right angle triangle, I can find the value AZ. AZ squared is equal to AB squared plus BZ squared. Therefore, AC squared is equal to 9 squared plus 8 squared, which is equal to 145. AC is equal to square root 145. That is equal to 12.0 centimeters to 3 significant figures. Let's move on to a real life example. Okay, in this example question, there is a ladder which is 6 meters long, resting against a vertical wall and placed on a horizontal ground. As the wall is vertical and the ground is horizontal, it forms a right angle here. I have represented the ladder with a blue line and it is 6 meters long. There are some instructions for using this ladder. It says that the bottom of the ladder must not be closer than 1.5 meters from the bottom of the wall. So this distance has to be at least 1.5 meters. How far up the wall can the ladder reach? So we have to calculate this vertical distance along the wall. Okay, so by applying the Pythagoras theory, I can find out the vertical distance. As this is a right angle triangle, by applying Pythagoras theory to it, h squared plus 1.5 squared is equal to 6 squared. Then by rearranging the formula, I can make h squared the subject of the formula. It is equal to 6 squared minus 1.5 squared. Therefore, by taking the square root of 33.75, I can find the h. The value of h will be equal to 5.8 centimeters. Since the answer must be given to one decimal place, h will be equal to 5.8 centimeters. To access more videos on other topics, please subscribe to my channel. Thank you.